This uninspiring grey box is, believe it or not, an amplifier from a sort of like 1960s ice cream van. One of my girlfriend's nephews has bought an ice cream van and is actually restoring it at the moment. And this is the amplifier from it, and apparently it doesn't work. I'm not sure if it's the amplifier or it's the it could be the speaker, I suppose. But I just want to check this amplifier out, and we need to try and find some information on it. There seems to be a bit of lack of information on the internet about who actually makes these amplifiers. And there's no schematic or anything like that. But I think it's going to be a fairly basic affair. I used two large bulging type connectors on the front here, as you see. Similar to the old Weller stations, soldering iron stations, but much larger. You can see this is a much larger connector. I'm assuming, and I'm only assuming, that one is the speaker terminal and one's probably an input, or maybe one's the power supply, maybe one's the input, and maybe a speaker connection goes in here. I'm not sure. Now we've got a pot on the front here for I assume volume, but apart from that, it's just a grey hammerite box, really. Nothing particularly exciting. There's a hole in the side here. So I think the thing is to pop it open, have a look, and then I'm going to try and see if I can find any information on what it's all about and who makes it, and maybe hopefully find a schematic. Okay, and open up inside, and we've got a I assume that's a line transformer. Maybe it's designed to run a line, probably a 50 volt line output. There's two chocolate blocks here that are in the corner. Probably go to a loudspeaker, but not sure. We need to have a further look. We've got like a matching transformer here, which would suggest that probably the amplifier is actually driving a set of germanium transistors. I'm not sure about that, but these transistors here certainly look silicon to me. These sort of sound like a BC108 and probably a 29353, something like that. I have to check the numbers and have a look. But first of all, we need to get this board out. Now, I did notice that someone's obviously been in here, and this nut's missing off this standoff here. So we remove these four nuts for a start. Lift this off and have a look. It's obviously been worked on at some point because there's some resoldering work gone on here. And then we'll just basically check these electrolytics, make sure they're okay. Not sure what these pots do. Probably one of them sort of like minimum volume level, and probably the other one's like, I don't know. If it's a push-pull amplifier, it's probably biasing for the output stage, something like that. But no sign of any burning or anything. Nothing obviously wrong with it. But we need to, first of all, we really need to get a schematic to make sure we connect it up properly. Failing that, we need to sort of look at the circuit and try and work out what's the input and what's the output. The connections are obviously been disconnected at some point, and could do with being made a bit nicer than that, a bit more something that's going to be a bit more reliable. Obviously it's going to be bumping around in the back of an old van, so we need something that's going to not, the wires aren't going to fall out and you're going to lose your jingles as you go along. But apart from that, really, it looks pretty unmolested. It's got these rivets on the side here, and I'm not entirely sure what they're doing, but they might be just the stays for the circuit board. You see this stay here doesn't seem to be doing an awful lot, apart from maybe holding the circuit board in place. And if that's the case, I think we're going to have to draw these rivets out, unfortunately, to get the board out. And the same the other side. But maybe if I'm lucky, I might be able to wriggle the board out. If I can drop this board down, maybe I'll be able to get this board past this this aluminium plate. But I think that's all that's doing is acting as a vibration stay. So I think what I'll do first is I'll try and get this board out and have a look underside and see if I can see what the output stage is. I'm expecting a TO3 in there to drive the output stage, maybe probably a AD149 or something like that, but it might be silicon, I don't know. Well, it could be a 3055. Let's try and get this board out and see if we can see what's going on. I've disconnected the leads, so we've got a bit more room to work in. Apparently this is a Harvin Pied Piper. Still not sure of the date, but it's obviously an early model. The later models seem to have a sort of like electronic EEPROM in them that will store the music in a sort of like an 8-bit audio file. But this was originally connected to a traditional sort of like music box sort of affair with like a ceramic pickup cartridge on it. And these are the inputs here. Apparently this is the power lead, and the speaker leads, as I thought off this line transformer, were indeed the speaker leads. So what I've got to do is now I've got to try and drill these out. I've loosened these bolts off, but these nuts off, but unfortunately the board won't come out. I need to get inside. I want to check everything before I you know, initialize it and power it up. Now I'm assuming one of these is positive. I'm assuming it's not like it's not running into a bridge. If it's running into a full bridge rectifier, it doesn't matter which way I connect these up with DC, because the bridge rectifier will correct the polarity and feed in the voltage the right way around. But I've got a bit of blue tape around here. I took a photograph of it to make sure I know where everything goes, but at the moment it does look like that is definitely the DC input. That is the input to the amplifier. 3 wires, I'm not sure why. It could be a screen lead for the pickup, and then the 2 sides of the coil. So you've got the push, the orange is the pull, and the green is the ground. Not sure about this. Can't find any information at all about these amplifiers apart from people showing pictures of them, but there's no sort of technical information about schematics or anything like that. But it shouldn't be a problem really, as long as nothing's burnt out, or the transformers are okay, and there's no reason to think that there is a problem with the transformers. It looks like the most common cause of failure is actually the actual speaker itself. All I'm interested really is getting this amplifier powered up, run it through a line transformer, which I've got somewhere. I've got a line transformer kicking around in the workshop somewhere, and we'll just ascertain that the amplifier does actually do what it's meant to do. Alright, I think we're going to have to drill these rivets out to get this board out, so let's try and whip the... All I want to do is, I don't want to drill all the way through this, I just want to try and drill out the aluminium head, and hopefully the rivet will just pop out. So just be careful. There's the head of that one, and the idea is you can just punch out the inner core. It's the same with that one. It's got the... You see the head spins when it's been drilled through. You really don't want to sort of do as little damage as possible to the case. There you go. They just pop out, you see. Okay, that should be the heads out. So in theory, if you get a pair of old wire cutters or a pair of pliers, I'm going to use a pair of old blunt wire cutters, just so you can see what I'm doing. And you can see the head of the inside of the rivet. You should be able to just pull that out now. You can get hold of it, of course. It looks actually like the whole plate's moving. Let's see if we can get the screwdriver behind it. There we go, you see the plates lifting. I hope you can see the plates lifting. There we go. And you see that, obviously you've got to be careful of that resistor there. Now the worst comes to worst, we can actually cut that head off with something, but I think we should be able to just pry this aluminium plate up. There we go. That's that plate out. I should be able to get some movement on the board in a minute, so let's just do the other plate. It's obviously very important. If you ever drill anything out like this, I mean it's common sense really, but I will say it, if you've got aluminium floating around inside on electronics, aluminium and electronics short out obviously, and you don't want that to happen. So There we go. That's just popped out of there. This one's going to be easier because we've got more room this time. There we go. That's popped out. So that's remove those two plates. Now, in theory, this amplifier should just lift out, which it does. So let's get this board out, and I'll video from here. Okay, that's the amplifier out, and indeed it is what I thought. It's a quasi-complementary OC29, so germanium output stage, driving this, probably this line transformer, or the transformer that was where is it, here. We have got a silicon TIP3055, which is basically a 2N3055. Not entirely sure what that's doing. I need to have a look at that, but that might be just a driver or something, but it seems to be a rather large transistor for the what it's doing. So what I'm going to do is I'm just going to go round and check these transistors. Obviously these are germanium, so they're going to have a bit of a leakage between the collector and the emitter. That's normal, you expect that on a germanium transistor. Nothing to be concerned about if you ever check a germanium transistor. They'll always have a collector emitter leakage of a few 100K, something like that. Also, germanium transistors have if you're checking it with just a normal diode tester, which you can do, you don't need to use a transistor tester, the forward voltage drop is only about 200 to 300 millivolts, whereas a silicon like this 3055 is here will be about 0.6 to 0.7, maybe even higher than that. So there's nothing obviously wrong here. The underside of it shows the pot for the volume control, and indeed it does say that it's a Harvin PP1. Not a lot of other detailed information about it. Unfortunately I can't find a circuit diagram. I'm not entirely sure what this transistor is actually doing. It might be sort of like a crude regulator, but it could be just driver for the push-pull stage, you know, before it gets to the transformer. So this is the current driver to drive the transformer, then it drives the main output stage, and then it drives the output line transformer. But no sign of any burning or anything. So basically what I'm going to do now is I'm going to go through, check some of the components, just make sure everything's okay, and then we'll have an attempt at probably powering it up. I'm just going to do a quick check on the output stage just to see if there's anything obviously shorted on it. So I'm going to do a collector emitter short first. So the CAN is collector, and on the left hand side where the pins are higher up, this should be the emitter. Okay, that's a bit suspect. Let's try it on the other transistor. Okay, that's the same. Well, that could be because it's driving across the transformer, so I think what I need to do is get the transistor legs disconnected and just check that. I'm going to check this silicon transistor down here. Let me just zoom in so you can see a little bit easier what I'm doing. And the CAN is the collector on here, so I think this should be the base. I've got a diode junction. You can't see the meter at the moment, but it's saying 0.53, and that should be emitter, and that's 0.55. So that looks good. Reverse it, shouldn't have anything, nothing. Sorry, that's the base. Yep. Okay, so that's clear. So that transistor looks okay. What I need to do now is just check these little driver transistors. These are just like silicon transistors, not pretty straightforward in checking those. And actually that one might not even be, this transistor here might not actually be wider as a transistor. Let's see what it is. Try and get a number off it, but it looks like it's a, oh, it's a BC108. Well, that's simple enough. It's an NPN silicon. So let's buzz it out. So NP, and so the base needs to be positive. Should have a beep. Should have a beep, he says. There's the base. And the leg's a bit twisted round. That looks like the base there. Okay, that's the transistor's looking a little suspect. let's have a look at this other transistor. Might have to remove that transistor to be tested. Trouble is, testing on boards is not the best way of doing it. Let's check this transistor here. Okay, 0.65. And nothing. Let's go the other way. My hand's in the way. It's not easy to check these things and video at the same time. Nothing. Got a diode junction there and diode junction there. So it's a PN. So this is a PNP transistor. Let's have a look, see if it says what number it is. BC 179. So yeah, that must be a PNP. This other transistor here, BC 461. I haven't checked to see what that is, but let's see if we can buzz it out, see what it measures. So just checking that now. Okay, that's looking a bit. Okay, that's, to me, diode junction there. Joints are pretty dry. 0.6. That could be germanium. That looks like a PNP as well. Okay, so that transistor checks out okay. Looks like it may be a germanium, might be a silicon. So I think I need to look that up, but it certainly looks like it's a PNP. So those transistors look okay. This one here, it's difficult to see which is the base on this transistor because it's been sort of like twisted to make the leads fit. But it's certainly not very clear. So I might have to remove that. And also, it's, I don't know if you can see that. That transistor there is discoloured. It looks like it's got hot. So maybe that transistor is fried. But let me just look this transistor up, make sure these. So it's this one here we've checked, and that's okay. This driver looks okay here. The silicon transistor looks okay. These look suspicious. I need to remove the leads off their emitter and base and check them again. But date code is 1974, so that dates the amplifier to around 74. This is quite an early amplifier. Apparently the van is sort of like, I think the owner said it was 79, but this is this amplifier has probably been sitting around for a while. I'm sure there are a lot of these in stock, and they just used to chuck them in the vans as they came along. So okay, we'll check the specs on that BC 461, and we'll come back and make sure it is indeed a PNP, and it is the sort of specs I'm expecting to see, which looks like maybe germanium. It could be a silicon, but I think it may be a germanium. Okay, that BC 461 is actually a silicon transistor, and it is indeed a PNP, rated at 2 amps at 60 volt. That tests fine. This transistor we know is correct and tests fine as well. These caps, I haven't checked those yet. I think I'm going to change those as a matter of course, because easy enough to change, and if I change them with good quality components, this amplifier will last another 50 years in theory. This transistor here, which is the BC109, I think I'm going to remove that and test that, and just ascertain that it's actually working correctly. Right, this is my tray of sort of like old obsolete components, or more obsolete than I normally deal with. I've got a number of transistors in here. We've got lots of silicon stuff. I've got a light going as well in the workshop, which is really annoying. Let's have a look, see if we can find anything. So I've got lots of silicon stuff, as I say, but we need to try and find some. I know we have got some. I have got some 8149 somewhere. Now I've had a quick look at the spec, and they look very similar actually, but I think if we change them, we'd have to change them in a pair. But most of this stuff in here is actually silicon. There's an AD149. Got a very short lead on it, but it's a working AD149. So we can find some more. I'm hoping to find the proper thing in OC29. It's another AD149. I'll do a comparison between gain and things just to see if we can actually use that. But they looks like you still can get them. There's a couple on eBay, OC2029, so it's not going to be impossible to get hold of. But the amount of transistors I've got here, I was hoping I would have something. See these things like BV20s. I think a lot of these are high voltage stuff out of line transformers for colour TVs and things. 2 and 305.5. Most of this stuff is, as I say, silicon, but no, I can't see any there. I think most of this stuff is all silicon. Yeah, 305.5s, MJ2955s, which is the PNP equivalent. Of course, there is always that option I can actually change these transistors to silicon, but that means rebiasing the amplifier, and I don't really want to do that. So let's see what we've got here. All these are BUVs. All these are BUVs. Obviously, put these in a tray. And some of the stuff isn't even numbered. Most of this is 2N numbers in here. 2SD, Japanese. More likely silicon as well. Okay, so it doesn't look like I've got an AD or OC29, so I think I'm going to have to order an OC29. I think I'd rather put an OC29. I'm sure the owner wouldn't mind paying a couple of quid extra for the proper transistor rather than an equivalent. It's not that critical. It's obviously doesn't matter how high, as long as the amplifier's got less than about 5% distortion. So yeah, what I'm going to do is I'm going to order some proper transistors, or I think I'm going to order, I might order a pair, see what price I can get a set for, and then we'll put the new transistors in and power it up and see how it works. Well, the OC29's turned up today, and they look like they've actually supplied me with a matched pair, which is great, because it's going to be the lowest distortion ice cream van in Cornwall, I should think, with a matched pair of transistors. So what we're looking at now is just going to do a quick check to make sure everything's okay. I wouldn't normally do this on video, but I just want to show you the slight difference you get with a germanium transistor relative to a silicon. Now, you've seen the forward voltage of a silicon transistor is usually about 0.5 to 0.7, something like that. That's the normal sort of voltage you'll get across the base emitter and collector. And also on a collector emitter junction of a silicon transistor, you won't get any reading at all. Now, let me just show you. This is the collector of the transistor. I'm going to go to the emitter here, and then you'll see that the meter is showing a leakage current of 1.45 volts. So there's a voltage drop of 1.45 volts. Nothing to worry about. Go the other way, it'll probably be something similar. 1.44 volts. We'll try it on the other transistor. So base emitter, the collector emitter, sorry, slightly higher, and again on this one, 1.6. Okay, now what we're really interested in is the base to the emitter and the base to collector. So this is a PNP transistor. So then the base of the transistor will be in the negative common connection, so we should have a diode junction here, and it's like a germanium diode, 0.1 of a volt, and across the emitter, difficult to do this, let's try just holding the lead on, 0.15 as well. Okay, and if we reverse our leads, we probably get the leakage current we had before with the collector emitter, sort of like 1.4, 1.5 volts. Let's have a look. Okay, it's nothing, it's good. And nothing there, so that transistor is good, obviously, and what was I expecting anyway. Let's do it again. So PNP, so the base is negative, diode junction, and the emitter, same thing, diode junction, and then we'll reverse the leads. Not really necessary, to be honest with you. It looks like these diode junctions are fine. Nothing, and nothing. So yeah, two new transistors are ready to go. I'm going to put those in. We'll get these two transistors in, and then hopefully power it up and see what it does. Right, so I'm going to drill the rivets out of these transistors. I don't know why they've riveted them on. I suppose it's just for cost, really. Drill these out. I'm going to replace them with nuts and bolts anyway. So let's drill the first rivet out. Heads off that one. Heads off that one. The transistor should be loose once you get a screwdriver under it. Let's do the other side. And you can see what happens when you drill the head off. Let me just zoom in so you see it's just left the shank behind. So basically the transistor will just pull past that. So you're just drilling the head off. You're not drilling through the transistor. You're just all you're interested in really is drilling the head of the rivet. I mean, I'm sure most people have done this anyway, but it's I'm not teaching you, trying to teach you to suck eggs. But there we go. We've got those out. So now the transistor should lift out fairly easily. If you get a screwdriver behind the transistor and give it a twist. There you go. That's the transistor out. That's the first one out. Obviously mark the connections up. Make sure you mark the connections up when you take these transistors out. I've done that already. So you can get those out, and then you can just push these out. Usually just push these straight out. Because they're only aluminium, they're fairly soft. Get this other one out. So those are two transistors. That's the one that had failed. You can see these are marked up with base emitter as well. So and obviously 1974. I think the van's 1979. I think it's a registration vehicle. So obviously the amplifier was made well before the vehicle was made. So what I'm going to do is I'm going to knock these out. I'm going to put silicon heatsink compound on here to aid thermal conduction, just give the transistor a bit more of a chance. We'll put some nuts and bolts in, screw it back together. Right, put the new transistors in, put them back on with some silicon grease, so we've got good thermal bonding. The original ones were riveted in, as you saw, and I replaced the rivets with screws. Main reason being, I didn't have any rivets in the workshop, but also the problem with rivets are they do relax after time, and that means that if the transistor becomes loose, it's a bit of a pain to get it retightened. You'd have to drill the rivets out. So I put a couple of screws in here with spring washers, so the transistor should stay warm, tight, sorry. So the plan now is just to see if this amplifier works. I'm just going to apply power to it. I've got a speaker connected up, and it's on the secondary of the speaker, so the line matching will be wrong because it's a line transformer. Actually saying that, I'll tell you what I will do. First of all, just to make sure the amplifier is working, I'll go to the primary of the transformer, which is this top connection here, and connect the speaker straight to that, so we've got a better match to the from the output stage to the speaker. This is a 16 ohm speaker, so it shouldn't be a problem. I'm turning the power on. You heard that pop, and we're drawing 100 milliamps, which is quite high actually for a quiescent current, but in theory if I touch this lead, there you go, amplifier's working. So this is also the gain control. These two pots here, I'm not sure, one looks like possibly some sort of feedback control, and the other one's bias, but of course that could be symmetrical clipping. Now I wouldn't have thought so on an amplifier like this, so I think the next stage is to connect it up to the audio analyzer and maybe just stick a signal in and see if it symmetrically clips. If it clips symmetrically, that's good. If it doesn't, I'll adjust some of these pots. And I'd like to look at the circuit and see if I can work out how that works, but it looks like that possibly that pot is actually all that's doing is supplying us with bias current. So we could adjust that, I suppose, just to see if the easiest way to tell if you've got bias current is adjusting is to actually measure it across the base of the transistor. But the other way, of course, is you could just look at the consumption on the meter and see if that's being affected at all. I seem to have managed to put my twiddling pot screwdriver down. So let's get a bit more organised. Let's get this thing on this audio analyzer and see what it does. Unfortunately, because the matching of this amplifier is so critical, it's very prone to going unstable. There's no way I'm going to get it on an audio analyzer. I don't know really on what I'm looking for in the audio analyzer anyway, because the distortion is going to be sort of like a couple of percent. It's not a hi-fi amplifier. but it's clearly working okay if you get it sort of the right matching. It's designed to have like a moving magnet input impedance, and I can't really match that with anything in here. I've got it connected to the audio generator or function generator, the PM5132. Yeah, Philips PM5132 fitting the input, and I've just connected the output of the transformer straight to this speaker, and you can hear the speaker's buzzing a bit, but you can hear that it works fine. Because of the matching, it's drawing quite a lot of current. These transistors are getting quite nice and warm, but the amplifier's working fine. Checked all the components. Not entirely sure what all these pots do. I think this one is sort of like a symmetrical clipping. I basically left them where they were. No need to change them. But the amplifier's working fine. That hopefully can be put back into the box and be sent back to its owners, where they can play their jingles on their ice cream van. Thanks for watching.